Hi, welcome to page 4, and we're talking about this is the corollaries to theorem 4.1.2, so corollaries to our superposition principle, and that is if, a constant multiple y is equal to c sub 1 y sub 1 of x of a solution, y sub 1 of x of a homogeneous linear differential equation is also a solution. And B, a homogeneous linear differential equation always possesses the trivial solution y equals 0. So, I think it's pretty self-explanatory. If you have a solution y sub 1 of a homogeneous linear differential equation, then you multiply by some constant that's also going to be a solution. And if we're dealing with a homogeneous linear differential equation, it will always have the solution y equals 0. Alright, so next we're going to talk about linear dependence independence. A set of functions f of 1, f of 2, f of n of x is said to be linear dependent on an interval I if there exists constant c sub 1, c sub 2, c sub n, not all 0, such that when we add all those functions together, multiplied by those constants, we can get it equal to 0 for every x in the interval. If this expression is 0 only when all the constants are 0, then the functions are called linear independent. So let's look at a few. So determine whether the given set of functions is linear independent on the interval from negative infinity to infinity. So for the first one, we're going to see if I can add my two functions together and see if that equals 0, but I'm going to multiply by some constants. Well, I can just multiply the first constant by 1, and the second constant I can multiply by negative 2. If I do that, I get negative 2x plus 2x. That equals 0, so that checks out. So we are linearly, I'm just going to call that LD, linearly dependent. B, f of 1 of x equals 2x, f of 2 of x equals 3x squared. So let's go ahead and write this out. We have two functions, 2x and 3x squared, and we're only allowed to multiply by a constant. Now, because we're only allowed to multiply by a constant, I can do everything that I possibly could to try to figure out, okay, what can I multiply by 2x that when I add it to 3x squared, it's going to give me 0. That's not 0. And because one's x, the other's x squared, then the only thing that would make that 0 is going to be 0. Alright, so that's the only way, because if I tried 1 and 3, it's not going to work because I'm still doing an x and an x squared. So they're not even going to be like terms because they have two different x's. One x to the first, second x squared. Alright, so this is linearly independent. Li for linearly independent. C, we have three functions this time. So we're going to add the three functions together. And we have x plus x squared plus x plus 1. And that's supposed to equal 0. Alright, so what we could try to do is we could try to multiply. First, the thing is, if we multiplied, say this by negative 1, get negative 1x plus, we could say that's a 0. We multiply that by 1. The problem is we're still going to get 1 left over. So this doesn't work. If we were able to find, another x value, if there wasn't that plus 1 there, then we could find another value. But because there's that plus 1 with that x, there's no way to multiply this x value that will make that equal 0 because you always had that plus 1. So the only thing that's going to work again is going to be 0. And so that's linearly independent. Alright, let's check the next one. Alright, so when n equals 2, so if we have two functions, the functions are linearly dependent if one is a constant multiple of another. Why? Well, I mean, because we can always just, if it's a constant multiple, we can always just take the reciprocal and multiply by that to get 0. So that's why. It's not really that helpful. Example 5 and 6. We have 5 cosine squared sine squared x. Pause the video. See if you can do this one on your own. Alright, so, oh hey, you unpause it. Hopefully you got it. Let's see if you did. Alright, so we're going to have our combination 5 plus, we have cosine squared x plus, and then we have sine squared x. And that's supposed to equal 0. Well, we know one thing is that cosine squared x plus sine squared x is just 1. So if I can make that 5 to be a -1, it works. And so it's linearly dependent. Hopefully you got it. Example 6, 0x e to the x. Is this linearly independent or dependent? Go ahead and try it on your own. Pause. Did you get it? We'll see. We have 0 plus x plus e to the x equals 0. All right. Now remember, it's linearly dependent if, we're able to multiply not all by 0. So let's multiply 0 by 1. All right. Well, we can just take care of the rest by having those as zeros, because not all are zeros. Those two are zeros, but that first constant is a 1. Because not all are zeros and that equals 0, 0 equals 0, this is said to be linearly dependent. So hopefully you got it. All right, last thing we'll talk about is the Wronskian for today, and that